Become an engineer. Mesmerize people with incomprehensible diagrams. Frighten your friends with terrifying mathematics. Confuse people with hundreds of abbreviations and acronyms. Build and use equipment that looks like it's from outer space. Make sure you hydrate properly. And there will be wrenches.
Hello everyone, my name is Chris Fenstermaker. I'm from Warren, Ohio, and I recently joined Goodyear, and I serve the role as a systems engineer on the non-pneumatic tire development team. My educational background, I studied mechanical engineering at both Youngstown State, where I earned my bachelor's degree, and then at Gannon University, where I earned my master's degree. My prior work experience includes General Electric in their locomotive division, where I was a test engineer, and then at the General Motors Lordstown Assembly Plant, where I was a manufacturing engineer, specializing in mechanical projects, machine repair, and tooling design. And then now here at Goodyear, I'm working in a research and development position. And I have been learning a lot since I started about 6 months ago, and I still have a lot to learn about tires in general, and then these new tires that we're developing. So I'm excited to join this program and work with you all, and definitely excited to see what kind of cool ideas you guys can come up with.
Hi, this is Coach Lettieri. I'm a senior R&D associate at Goodyear, and I work on the non-pneumatic tire team. I grew up in New York, but I have a bachelor's of science in mechanical engineering from MIT in Massachusetts. And while I was working for Goodyear, I received my master's degree in mechanical engineering at nights at Case Western Reserve University. I've been at Goodyear for 26 years, and I started my career in research working on vehicle dynamics, learning how tires affect the handling characteristics of cars. I've also worked on tire electronics, things like RFID chips in tires, and more recently I've joined the innovation group and I'm working on non-pneumatic tires. Non-pneumatic tires are tires that don't require any inflation pressure, no compressed air to function, and in fact it's part of the project you'll be working on to see why you'd want a tire that cannot go flat. Now a little bit about the different kinds of degrees and job opportunities at a tire company like Goodyear. So research and development in tires involves lots of different kind of fields of science and engineering. So tire construction engineering is the art of developing the cross section, the different plies, the different tread patterns and so on that comprise the tire. And that's typically done by mechanical engineers with a Bachelor of Science or sometimes a Master's of Science degree. Of course, there are many different materials in a tire, and we're constantly researching and developing new ones. And that is typically done by people with either a polymer science background, material science, chemical engineering, or chemistry backgrounds. And we have degrees of all levels, bachelor's, master's, and PhDs there. In the area of tire testing, tire vehicle interaction, and finite element analysis, those are areas where we also use mechanical engineers and also system engineers, which is actually a new and growing field. And those are typically bachelor's, master's, or PhD levels. We already talked about tire vehicle interactions like handling. Tire testing is exactly what it sounds like. Finite element analysis is the modeling of the stresses and strains that are present in tires as they're subjected to the forces during vehicle motion. And finally, we have manufacturing, which is all over the world. We have opportunities in manufacturing in different plants, and those are typically mechanical engineers or industrial engineers that work on the machines, design the machines, troubleshoot the machines, and of course also electrical engineers who design circuitry, design the equipment, and also the controls. Electrical engineers often are the ones writing the software to control all the machines. And again, those are usually bachelor's or master's degrees. Before we get to the project description, I'd like to talk a little bit about design methodology. A lot of times people think designing products or services is kind of a straight path. You know what the product is that you want to design, and you just kind of go straight to that. That's not always the best path. I kind of think along the lines of a golf course. So if you can see here, if you're sitting here at the tee and the cup is out here, the pin is out here, the shortest path between point A and point B is this straight line. But you'll notice if I just hit the ball along that line, I'm crossing trees. I'm actually going out of bounds, right? So if I drop the ball here along the line, I would actually take a penalty. I've got to carry this water, and really it's just way too far for me to go that way. So lots of risks associated with just trying to go straight in one shot. Alternatively, you might look at the course and make 2 or 3 shots to get to the pin and manage your risk. Well, if you can hit it really far, you might try to go the blue curve, right? Land the ball on your first shot here, try to go directly to the green. Still some risk. I got to go over this water, right? If I want to be more conservative, I can reduce the risk by shooting the ball out here and going along the water, but now I'll probably need a 3rd shot, right? So we manage the risk by doing these iterations, okay? And we can see a little more clearly, right? Obviously, in this long straight shot, I wouldn't be able to see the goal because of the trees, right? This way I can at least see where my next shot has to go. And that's how we use iteration in design. So a little bit more specifically, we look at iteration design or iterative design as a cycle, right? It's not a straight line. So like all good engineering, it should start with some thinking, right? And the product of thinking, of course, are ideas. So we have ideas, and then we take those ideas and we want to analyze them. And the process of analyze them, then we result in predictions. So we make predictions about what will happen concerning our ideas, right? But we can't really test those predictions until we build something. So the next step is building. And what are we building? Well, we're building prototypes. And the prototypes are going to be used during experiments, which will generate test data. And then we'll compare. And what are we comparing to? Well, we're comparing the test data and our prediction. And then we'll document the results of that so that we don't forget and so that other people can benefit from the study as well. And then we'll go through the cycle again, thinking about any discrepancies between the prediction and the test data, which will give us some new ideas. We'll analyze those, build them, experiment, okay? And we'll keep doing this cycle. And what will happen, hopefully, is the discrepancies or the differences between the test data and our predictions should get smaller and smaller each time we go around. And that's the process of learning, right? At the beginning on your first cycle, your predictions may be way off. There's going to be things you hadn't even thought of. But as you go around this circle, you're learning each time. And each time your predictions will get a little bit better. And before you know it, your product is performing the way you want it to.
The inspiration for this project came from NASA's Mars exploration rover named Spirit. This thing landed on Mars in 2004, and then 5 years later it got stuck. So NASA spent the next 5 years trying to develop and test for plans to get it unstuck, which they were unsuccessful. So they threw in the towel, and now they called it a stationary science platform. So this image gives you an idea of how NASA was simulating the rover's situation on Mars. And they tried different ways to program the rover to do different maneuvers to try to get it to free itself. And it was unsuccessful. But here you can see they have this sand pit, and they use this rock to wedge the body up so that not all the weight was on the tires, and the tires wouldn't have all the traction that it needed to continue to move along Mars. And so now we come to our problem statement. How might we design a tire for a future Mars rover with improved mobility? So first, let's look at the primary functions of a tire. A tire needs to do three things. It needs to carry the load, it needs to absorb energy from small obstacles, and it needs to use friction to enable the vehicle to start, stop, and turn. So a tire is pretty impressive in that it can carry quite a substantial load compared to its own weight. And then also tires need to be resistant and developed for the environment they're going to be in. Naturally, a road tire is significantly different than an off-road tire. Same with a car tire is significantly different than a truck tire. And then how a tire absorbs energy from small obstacles is that the contact point, the tire is able to flex in a way that it envelops the obstacle, as opposed to transmitting that force through the vehicle and to the passengers. And good traction requires a contact patch on a tire, not necessarily a line or a point, but it's a whole patch of surface area that gives good contact between the tire and the road. And for soft terrain, it's important to have edges that dig into that terrain to allow the tire to start moving and keep moving. So we should keep that in mind, because we definitely have a soft environment with our sandbox. Now let's take a look at a schematic of the rover we'll be using for testing. This is a top view of the rover. Here's the rover body with the 4 wheels. These wheels here are free rolling, and they will not have any tires on them. But these are the front wheel hubs, and here is our drivetrain system. We have a motor here that has 2 shaft outputs, one on each side. So this side is coupled to this wheel hub, and then this side has a shaft extension, ball bearing assembly, and then we're coupled to this wheel hub over here. And now we'll take a look at the drive wheels that you guys are going to be developing tires for. Over here, this purple piece is the wheel rim. That's where you will attach your tire. And one thing to note is that your tire must not be wider than this wheel rim, and it also must not be able to slip along the wheel rim. So here's an example of the tire on the wheel. And then here is where we put the tire and the wheel rim onto the wheel hub. And this blue center hub is what is going to be bolted to the rover. Okay, and now we get to the fun part where we do the testing. And unfortunately this year we'll have to test at Goodyear with myself and Joe Lettieri. So we'll have to record the test results, take the data, and then send you guys the videos and the data. And you can post-process that and see how good your tires did. But here we have our test setup includes this box of sand, and we have a string that's attached to this pulley system, and on the other end here is a load cell with some weights and springs to balance everything out. And here the computer will record the data from the load cell, so as the rover moves forward through the sand or the Mars terrain, this load cell will experience the pulling force and record it on the computer. So here's how the data output looks like from the load cell. So the load cell gives us the drawbar pull force in newtons, and that is plotted against time in seconds. And here we can see from rest, the rover starts to move forward and applies tension to the string and to the load cell. And then as it continues to dig through the sand and push forward, we kind of get a trend as to what traction we're getting from the tires. And you can see there's a lot of what we would call noise, all these jagged edges. And that's where we see a lot of slippage, where it's not pulling as efficiently as it was, say, back here. And then finally here, it keeps trending upward, meaning the rover keeps moving forward. It's not stuck yet. It's struggling, but it's not stuck. But then once it tapers off and then even starts to level out, that's when the rover is stuck and the tires are no longer doing their job. So here's a good benchmark for you guys to do better than our tire did with just this foam.
In soft soil testing, the consistency of the surface is very important. So we have a rake that we have designed to groom the surface to get a very consistent soil path. The load cell is attached to two springs, and there's a counterweight on the other side of the pulley so that there's no tension at the beginning. But as I pull on the string, I'm increasing the force because of the springs.
And here you see how the center hub, which is in blue, is removable and actually will be affixed to the car. And here you can actually see the rover in motion, pulling the drawbar string. And the graph is being collected at the same time. This is the materials kit that you will receive from Coach Griffith. It has some foam rings, some mesh, some insulation, some cable ties here, some sandpaper, and some other foamy and rough materials. And then you will receive two wheels on which you need to build your tires. And remember, your tires shouldn't be any wider than these wheels. And then you will turn these wheels and tires into Coach Griffith, and we will pick them up, slide them onto the vehicle, and test them at Goodyear. Remember that there will be torque applied by the vehicle, so you have to make sure that your tire will not slip on the wheel when the wheel is turning. So they need to be glued on there or taped on, or somehow they have to be attached firmly to the wheel. And finally, we can talk a little bit about the timeline, and some of this might change, so pay attention to Coach Griffith. But the way things stand now, the project kickoff will be Monday, August 31st, and you'll receive this video, I hope. And on September 4th, which is Friday, you'll get the material kit that we spoke about. and you'll have 2 or 3 weeks to put together 2 tires, and then by the 24th, which is a Thursday, September 24th, you need to deliver those 2 tires to the school, and Coach Fenstermaker and myself will pick them up from the school, and we will test them at Goodyear on Friday, and we will deliver the results to you on Monday, September 28th. And then your final presentation is due on October 2nd. And again, Coach Griffith can give you more details on all of this. So on behalf of Coach Fenstermaker and myself, we wish you the best of luck. We will be in touch with you during the time where you're fabricating your tires to see if you have any questions or if there's any problems. And Coach Griffith knows how to get in touch with us if you have any further questions. Okay, best of luck to all of you. Bye.